let me just give you like a brief introduction about how Kubeflow works. So as in the first step, you see that we have the Kubeflow dashboard. Now, to show you how Kubeflow works, let me just select notebooks. I will just spin in up a new notebook. So we select new notebook, we just give a random name. And at this point, we can actually select which image we want our notebook to use. And we already provide a number of images here, which they integrate, they feature the main machine learning libraries like PyTorch and TensorFlow on different architecture, both CPUs, but also GPUs. But also, if you have your image that you want to run, you can just select custom image and plug your custom image there to actually start to use your image. Let me just start with the Jupyter CPy for the purpose of the demo. Let's also pimp up a little bit the resources in terms of CPUs and RAM. Here you can also configure the volumes, and you can also configure the notebook to access to Mini.io and MLflow, which will be critical for this demo. Now we can just launch this notebook, and while we wait for the notebook to be alive, let me also show you an interesting repo that you can use to get started. So we have this repo, which is Charm Kubeflow UATs, which contains a set of examples that you can already use and start to get started with Kubeflow. For different architectures, so CPUs, also for GPUs, for trainers. So it contains a number of interesting notebooks that you can use to get started. And we'll just use one of these notebooks for the demo today. So what we're going to do now is just to clone this repository. So we select the URL here, and then we go back to Kubeflow, where we will be going into the notebooks and then cloning this repository. So we can go to the notebooks, then we can clone the repository. We just paste the URL, and there you go. We have the repository cloned locally in our notebook. So we can go into the folders, and we can just select one of the example that we have in the folder. So for this demo, we're just going to give you a little bit of a full overview of how you can use Kubeflow on a prediction data set, so to predict house prices. And we'll show you the entire workflow journey from exploration and prototyping of an MLOps, of an ML model. Then we'll use MLflow to do the experiment tracking, and then Katib to do hyperparameter tuning. And finally, we'll be using the pipelines to do the preprocessing, the modeling, and the deployment of an inference service using KServe. So let's get started. First of all, we install all the requirements that they are required to run these notebooks. As you can see here, all the various Python packages are being installed. And then we can start off with the data exploration part. So in this first part, we just import a data set, the California housing data set from scikit-learn. And we start to actually explore this data set. So you see here a little bit how the dataset is stored, and we have a target variable, which is the prices of the housing. So we can, for instance, start to just plot the distribution for this target variable. Of course, the exploration can take many forms, but for the sake of it, you understand how you can do with the notebook. The next step is, of course, training a model. So to train a model, we'll be using scikit-learn, train a model on this target variable. And it's usual stuff, so splitting between train and test, and then creating a pipeline. In this pipeline, we are using a scalar and then a random forest regressor with a number of estimator. Then we just fit, and we score the model that we have just been fitting. As you can see here, we are fitting our ML model, and there you go, we have the result. However, one critical part is that here, the training was done locally, but we want to store all this training and this experiment now on MLOps, or on MLflow. So to do so, we just decorate the script that we have just seen with the MLflow SDK to store all the information about the training. So for instance, here, we are storing the score on the test set, as well as we can also store the model. So when we run this script, you'll see that we will be effectively storing this information in MLflow. So if we go back to the dashboard and we go to the MLflow dashboard, we'll see now that we have an experiment here, which is the experiment the experiment that we have just been running, where in this page, we summarize the parameters that have been used, as well as also the metrics of the training. So for instance, here we have this R2 score, which is the general metric used in regression problems. All right, so now we have stored this information in MLflow. However, you see that here we have also stored the model that we have been training that can be later consumed. Let's go back to the notebook, and let's now use Katib to actually optimize the number of estimators for this modeling. So basically, Katib provides the ability to do the so-called hyperparameter tuning. And in order to do this, we have to first define the training function, which has some parameters. So the parameters in this case is the number of estimators. So we want to try to model do the modeling for different number of estimators and picking what is the best parameters. So as you can see here, we are implementing the objective function, and we are providing this objective function to Katib. So here we have the objective function as well as the parameter space that we want to use, as well as the objective metric that we want to use and whether we want to minimize or maximize the metric. And then the number of tries. So when we run this, we will actually be given a link to the Kubeflow dashboard where we can actually follow the experimentation, where we can actually follow the various experiments that they are being run on the background by Katib. So as you can see here, there is the page that summarizes the experiments. And as you can see, the experiment has just been created right now, and now it is running. So running means that different trials with different parameters are being run on the background. And in this page, all the results will progressively be gathered. So as they are gathered, also like a plot will appear, which will show how the output variable, so the R2 score, depends on the various parameters. In this case, the number of estimators. And as soon as more trials comes in, this plot will be populated with more lines. And at a certain point, all the trials will be run. And as you can see, indeed, the experiment has finished. And at this point, we can also, drill down a little bit the results in the plot. But also there is a tab, trials, where all the various trials are summarized with the number of estimators and the score that is associated to. And by the overview, we can also select which one was the best number of estimators, which was 181 estimators. Now, what we're going to do is actually to implement a pipeline. So we will do exactly what we have seen right now. So the data processing part, the model training, and at this point, also, we will be consuming the model that we just trained and deployed using KServe, using a structured pipeline as provided by KFP. So first of all, we need to define the various steps, the various step of the pipeline. So from reading the data, which is what you see now, to when this data, which is read, is then consumed and a model is trained. So for instance, here you see that the input for this component is also the number of estimator. And as you can see also in this case, we're using MLflow such that whatever this experiment and also the model that we are going to train is going to be stored in MLflow. And the output of this part is, of course, a model URI. So the URI on MLflow such that we can consume this model and deploy it using KServe, which is exactly what we are doing in the third step of our pipeline. So basically, now we have defined all the different components, the processing, the training, and the deployment. Now what we have to do is to put them all together in a full pipeline. So in order to do this, we still use some Python code to put all the things together. Of course, the input also for the pipeline is, again, the number of estimator. And then we just use we just put together the three different steps that we have just defined. And then what is left to do is just to trigger this pipeline. So as you can see, before triggering the pipeline, we just use the number of estimator that we got from Katib, which is the best number. And as we trigger the pipeline, we just get a new link back to the Kubeflow dashboard where we can follow the progression of the pipeline. So first, the dataset is created, then training the model, and finally deploying the model. Now, this process is going to be quite fast. We have sped up a little bit the video just to fit within the webinar, but overall might take a few more minutes, but you'll see that one after another, the very step becomes great. And by the way, what you can also do from this UI is also to explore a little bit more the various steps. So you can select one of the steps and see the various input-output of the step, or some task details, or even some logs. All right, so now with this step, we have, as I said, train a new model that you see here, the regressor pipeline, which is now stored on MLflow. And now we have also deployed an inference service using this model. And you can query this using Kubectl. So if you query for the inference service, you see that now we have a housing regression regressor inference service. And we also have a pod, which holds the model and allows to serve 4 requests for query the model and to get some prediction. And that's exactly what we are doing in this final step. We are actually taking some, we are actually going to perform some prediction just by doing a post request to the model. And as you can see, we are getting some inference here. So KServe is great to deploy models that you have just trained, as we have just shown, but you can also use it to even deploy existing models. So for instance, in this case, we are deploying an LLM model. So you can also consume some LLM models that they have been pre-trained, still using KServe. Similar as before, also here we are going just to install some requirements first. And then also it's quite important to give a name to this LLM model, so to this inference service. So we're going to call it LLM model. And then in a very similar way as we have done before, we're going to deploy a model from Hugging Face using still KServe. When you do this, you might actually need to give some extra arguments and also some constraint when it comes to the resources. But in a very similar way, you can actually use KServe SDK to deploy also this LLM. And also in this case, we just wait a few seconds for the inference service to be up and running. And we can also check that indeed now there will be another inference service. So as you can see, we are querying for the inference services. Now we also have the LLM model beside the housing regressor one. And we also have a portal which has the model and serves request for this model. And similarly as before, we can also use, we can also define an HTTP request to get some inference and some results out of this LLM model that we have just deployed. So really, this should give you a little bit of an introduction of the kind of workflow that when you are a data scientist or data engineer, you can do using Kubeflow, from when you do the data exploration to when you actually structure your analysis in a better structure, like training the model, storing the model into MLflow, consuming the model using KServe, or also consuming some LLM models that you have already trained.